Alright, so this is going to be a very short video on how to read solubility graphs. Okay, for solubility, we're talking about how much solute can be dissolved in a solvent. So something more soluble, more of it can be dissolved in a solvent than something that's less soluble. Right, so here we can see a table where it's telling you that 203.9 grams of sugar can be dissolved in 100 grams of water at 20 degrees Celsius, right? And 36 grams of table salt can be dissolved in 100 grams of water at 20 degrees Celsius, right? So this tells us that sugar is more soluble than table salt is, right? So two key points. The amount of water, the amount of solvent is important, which is why that's always going to be listed, 100 grams. And something about water, 100 grams of water would, the volume of it would be 100 milliliters. Okay, and then the temperature. More, solubility depends upon the temperature. As you increase temperature for solids, more of that substance can be dissolved, right? So like when you're dissolving sugar, you heat the water and more sugar can be dissolved than if it was still cold water. Right now, gases act oppositely. As you heat the substance, less gas can be dissolved. So if you remember from our Diet Coke and Mentos experiment, as we heated up the Diet Coke, the carbon dioxide gas that creates the explosion, it wanted to come out more when we heated it up, and we had a larger explosion. And that's because it doesn't dissolve, it doesn't remain dissolved. The carbon dioxide gas doesn't remain as dissolved when the Diet Coke is heated. All right, so there are three types of solutions. There's unsaturated, saturated, and supersaturated. Right. I like to give the analogy of a train and passengers on a train. Okay, so if we think of an unsaturated solution holds less solute than what can actually be dissolved at that temperature. Okay, so think of a train that only has a few passengers on it and a lot more passengers could fit in there. That would be an unsaturated solution. Now, a saturated solution holds just the right amount of solute in it at that temperature. Okay, so think of that like a train, and it's full of passengers. No more could fit on there, but it's definitely reaching its capacity. So that's a saturated solution. Now, a supersaturated solution holds more than what would normally be dissolved at that temperature. Okay, so supersaturated solutions are very unstable. They're created in under special conditions. And anything that upsets that condition causes the solute to drop out. All right, but this would be like a train that's like in India where they don't have enough infrastructure to meet their growing population demands, and they ride the trains like this, and they actually really do. This would be a supersaturated solution. It's holding more solute than what would normally be held at that temperature. Okay, and we make supersaturated solutions when we want to make rock candy, right? Crystals form that way in a supersaturated solutions, and the solute starts to drop out and crystallize. Okay, so there are supersaturated solutions around. They're just not as common. Right now, read in these graphs. Right, so what the graph is showing you, on the y-axis, it's showing you the solubility of the solutes, of any solute that's on the graph. And the x-axis is showing you the temperatures. Okay, and the curved lines are showing you it's the saturation point. How much can be dissolved of any solute at that temperature? Okay, so here's an example of how to read one of these graphs. So at 40 degrees Celsius, 130 grams of sodium chlorate, NaClO3, can be dissolved in 100 grams of water. Okay, so we're going to look for 40 degrees down on the x-axis, and then we're going to look for 130 grams over on the y-axis and find that point. Match up those two, the 40 with the 130, and we have the point right along the sodium chlorate line on the graph, the NaClO3. So that's a saturated solution because it's right on the line. Right. Okay, so for any solution, all points along the lines would said to be a saturated solution. Right, so test questions and stuff would ask how much could be dissolved of a certain substance at a given temperature. And you just find that temperature, carry it up to the line, go over to the y-axis and find the amount. All right, now another thing that you have to be able to answer with one of these graphs is tell whether the solution is saturated, supersaturated, or unsaturated. So it'll give you a temperature and an amount dissolved. And so you just match up those 2 points and see if the point is below the line, it's unsaturated, on the line, saturated, above the line, supersaturated. So here's an example. At 80 degrees Celsius, a solution containing 120 grams of potassium nitrate, KNO3, is unsaturated. Okay, so we find the 80 grams, 80 degrees Celsius on the x-axis, carry it up to where it meets the point for the 120 grams that's on the y-axis. Okay, and then we're looking for KNO3. So you find the curve of the KNO3, right, and the point is below the KNO3 line on the graph. So it is an unsaturated solution. Okay, in this example, we have 100 degrees Celsius. So you find the 100 degrees Celsius on the x-axis, and then you find the 160 grams on the y-axis, figure out where that point would be, and then we're looking for potassium bromide, KBr. Okay, so the point happens to be above the KBr line. So that would be a supersaturated solution, right? So hopefully this helps. You read those graphs